In high school, I was always really interested in energy and physics. And once I learned about how we can use nuclear reactions to create almost limitless energy, I knew I wanted to become a nuclear engineer. So 22033 was a class in which teams of students would decide and create their own product that related to nuclear science and engineering.
It's basically a very intense semester-long course where you get in groups and you try to identify a problem in society or in technology that can be improved upon or solved using nuclear technology.
The purpose of this class is sort of to teach the design process in engineering and scientific design using a lot of the principles that we have learned over the past few years in like a more concentrated setting.
So the way the design course works is we get the students' creative juices flowing with a mini project.
The course started off with a very startup feel. It was, that build fast, like break things. And so it sounded kind of easy at first, but it very quickly, kind of demonstrated to us why classes like this are important, because there's a lot that goes into it.
After that, we have the students split up into groups of 3 or 4, identify a societal need that could be solved with nuclear physics or engineering, come up with a holistic design approach, and then actually implement their physical solution. Whether this is a simulation of something, a product, an improvement to a reactor, a new plasma diagnostic, or in the case of this year's winning design course, a cosmic ray neutron-based soil water meter called NuDrop.
I think my favorite part of the course was the sort of collaborative aspect of it. As the project moved on and we discovered like different areas that needed work, we were really able to sort of partition what was getting done to play to everybody's strengths.
We have someone who's good at thermodynamics, we have someone who's good at materials, we have someone who knows space stuff.
During the final presentations, we were judged for different aspects of our product, how viable our product was technically, the issues that we faced and resolved, and also touching a little bit on the economics and the business side of things.
Most of what I learned was not what I was expecting to learn from this class.
We really had to look at things from more aspects than we ever done before in our 4 years of undergrad. From the business side and also the technical side, and how those two things meet together, and how you need to look at both of them for a viable product.
There's a lot of preconceptions about what is nuclear science and engineering, and it's a lot broader than most people would think. Nuclear to me is the ultimate integrated engineering discipline, because you have to take aspects of physics, chemistry, mechanical engineering, thermodynamics, ethics, social science, policy, and lump them all together in order to create working solutions.
The degree that you get from nuclear science and engineering is not just one that tells you how to run a nuclear reactor or calculate criticality of some lump of uranium. It actually sets you up quite a bit with the amount of options that are available to you to pursue through classes and research and the graduate level work that undergraduates are able to do.
And especially with the field being so varied as it is now, there's so much going on in nuclear medicine, so much in energy, so much in detectors for safety, for a million other things. There's just a lot that I could do with the knowledge that I have.